In this video, we will discuss the problem that is count subarrays with given XOR. Problem says that we'll be given an array of integers and will be given another integer k. We have to count the number of subarrays whose XOR is equal to k. So basically, if you see the first test case, that is 42264, in this particular given array, there are 4 subarrays which have got the XOR equal to 6 here, because the subarray that is 42264, this particular subarray has got the XOR as 6. Apart from that, the subarray 4 comma 2, it also has got the XOR equal to 6. Apart from that, the subarray 226, this also has got the XOR of the elements as 6, and the single element 6, this particular subarray also has got the XOR as k, that is 6. So there are 4 such subarrays which have got the XOR equal to the given k value. Correct. How can we solve this problem here? So in order to solve this problem, the very first approach that we can apply is we can check all the subarrays in a brute force manner, and we can check if the XOR of the subarrays is equal to k, then we can increase the counter here. So the brute force approach will be that initially you will try to iterate on all the possible subarrays and then check whenever the XOR for a particular subarray is equal to k, then you will increase the counter here. So what we would be doing is, initially you can say that my starting pointer or my I will start from here. Okay, and starting from this index, we'll try all possible subarrays, right? So initially you can see that one subarray will be 4, another will be 4, 2, then another will be 4, 2, 2, another will be what? 4, 4, 2, 2, 6, then another will be 4, 2, 2, 6, 4. So these subarrays will be there starting from the index I, you will have these subarrays. So you'll explore all of them. Now after that, what will happen? Your I will come here, and then you'll explore this particular subarray, that is only 2, then 2 comma 2, then 2 comma 2 comma 6, then 2 comma 2 comma 6 comma 4. So we'll explore all these subarrays here. Correct. So the thing here is, basically, if I'll keep my I pointer here, so initially in my XOR, like let's say if I'll take a variable XOR here, so initially my j will start from here and we'll take the XOR of this guy. And if the XOR is equal to k, then we'll increase the counter. So initially my counter will be equal to nothing but 0 here. As of now, my XOR will be what? It will be 4 only. Then after that, my j will move further and j will be here. Now we'll take the XOR of this element as well. So XOR will be 4, XOR 2. So this particular subarray 4 comma 2 we are trying to consider. Now the XOR for this will be equal to 6, obviously, because we have seen this in the output, expected output as well. So what will happen is the counter will increase to 1 here. Now after that, what will happen next is, next up you will increase your j. So your j will increase and j will come here. Now you will take the XOR of this. Now XOR 2 also will be there, and this is not equal to k. So in that case, you can move your j further. Now j will move further. This element would be considered, and you will take the XOR as 6. Now still it is not equal to k. So now you'll increase your j again. Now j will move here. So we are taking the XOR of this subarray starting from index I till this complete index j. Now XOR 4 will be equal to what? This XOR will be equal to 6, obviously. It's equal to k. So increase the counter. Now counter becomes equal to what? 2 here. Now after this, what will happen? We have considered all the subarrays starting from this index I using the j pointer as well. Now after that, my I will proceed further. Now I will be standing here and my j will start from wherever my ith index is at. Now my j is here. Now my XOR is as of now equal to 2. Is it equal to k? No. Then my j will move further. Now it will be here. The XOR 2 will be added here. Now after this, still the XOR is not equal to k. So my j will move. Now j will be here. I'll take XOR k, XOR 6. Now it's equal to k, so increase the count, counter becomes equal to 3 here. So this way we'll keep on exploring all the subarrays. Basically the concept is that starting from an ith index, we'll consider all the subarrays from there. So if I'm at this ith index, initially I'll consider this subarray, then this subarray, then this subarray, and then this subarray. So my j will keep on moving further. You can see that I'm using 2 loops, so that is why the time complexity would be order of n square here. Let's discuss the code for it. You can see here, what I'll be doing is, I'll be initially declaring a result as 0. Then after that, what I'll do is, I'll take a XOR variable initially as 0, and I'll start from the ith index. Now I will start from 0 till the length of the array. After that, my j will always start from I till the end of the array, because we have to start considering all the subarrays starting from the ith index till all the particular jth indexes, right? Now after that, what will happen is, we'll take the XOR of this jth element, and after taking the XOR, if the XOR is equal to k, then we keep on increasing the result or the counter here, and at the end we return the result or the count of the subarrays which have got the XOR equal to k. Now you can see here in this particular approach, there are 2 nested loops, one inside the other. So that is why the time complexity will be order of n square. The space complexity is going to be order of 1, because we are not using any extra space here. Can we optimize this a bit more? Yes, we can do that. Basically what we can do is we can try to use hash map as well as the prefix sum, or you can say the prefix Zor concept, because we'll be taking Zor here, so you can say that the concept will be prefix Zor here. How does it help us? We have to understand this. So one of the things that can happen is if I'll start taking the prefix in the array, prefix Zor in the array, and the Zor till this particular index is basically equal to nothing but x here. Okay, now suppose that this subarray from the starting till this point had the Zor as p, and let us say that this particular subarray that is there, it has the Zor value equal to k here. Correct. The subarray from here to here, this blue region has the Zor as k. Now what I'll do is I'll keep on storing all the Zors, like as I keep on taking the Zor of the elements index by index, I'll keep on storing all the Zor values inside a map. Okay, so that whenever I want to retrieve them, I can retrieve them easily. Now, if you will see here, I can rewrite this equation as what? I can write this equation as p Zor k is equal to what? It's equal to x. If I take Zor with k on both the sides, what will happen? It'll be like p Zor k. Zor with k is equal to what? It's equal to x Zor k. Now I can write this as k Zor k will cancel each other, because if you take the Zor of the same elements, it will be 0. So p will be equal to nothing but x Zor with k here. P will be equal to nothing but x Zor with k. So the thing is, we can say that if I have got the Zor till this particular index as x, correct? I've got the Zor till this particular index as x, and if x Zor k is present, what is this value? This is basically x Zor k. P, because I have derived that p will be equal to what? X Zor k. XOR k is present. If I have seen a value that is XOR k before, if I have taken the XOR of the array, and in my map if XOR k is present, so this means that in between this subarray, this blue subarray will be having the XOR equal to k. Then only at this point I'll get the XOR as x, because I told you, if you will see here, I told you that suppose that the starting from the starting till this index, my XOR was equal to p. Okay, and which will be stored in the map obviously as I keep on taking the XORs, and suppose that this blue region might be having the XOR equal to k. Now as of now, whatever index I am at, let's say the XOR at this index is equal to x here, so I can write the equation as the XOR of all these elements, that is p XOR with k, will be equal to x. That is fine, because the XOR of all the elements cumulatively till this index will be p XOR k, which will be equal to k, which will be equal to x. Now p XOR k, because I'm taking XOR k with on both the sides, so you'll see that p XOR k will be equal to x XOR k. Now p will be equal to what? P will be equal to x XOR k. So basically p is equal to x XOR k. So what I'll try to identify is, I'll try to identify inside the map, does there exist x XOR k or not? If as of now today I'm having the XOR value equal to x, and in my map if I have seen the x XOR k value, in my map if x XOR k value is present, if there is a subarray from the starting till a particular index which has got the XOR value as x XOR k, then this means that internally there will be a subarray like this blue region which will be having the XOR equal to x, because actually what will happen? Actually x XOR k will be equal to x. So how do I get this x? For getting this x, this particular subarray should be having the XOR equal to x XOR k. This particular subarray should be having x XOR k, and there must be existing a subarray with XOR as k. Then only I'll get this final XOR x here. I hope you got my point. So you can see here that if like I have identified what will be the p value. So if there exists a value that is x XOR k inside the map, if there exists a value that is x XOR k inside the map, if I have seen a XOR value from the starting index till a particular point that is x XOR k, so this basically indicates that there must be a subarray with the XOR as k. That is why we are having this value x here at this point. You can see here, because x XOR k will be equal to x here. Correct. So if I'm able to identify, if I'm able to get this x XOR k value inside a map, right? If it is present, this means that there will be at least one subarray which will be having the XOR equal to x. Now there might be multiple also, depends. If the x XOR k is present two times, then there will be two such subarrays which will be having the XOR as k internally. So this is the main concept behind this problem here. That one of the things is that if you keep on taking the XOR and the XOR itself is equal to k, then you have to increase the counter. Otherwise, if you are at a particular index and your XOR value is equal to x at that point, if your XOR value is equal to x at that point, and you try to identify that x XOR k is present or not, if x XOR k is present, this means that there will be a subarray in between which will be having the XOR value equal to k. That is why this scenario exists. I hope you got my point. And whatever is the frequency of this XOR key, that many subarrays should be added in the result here. Now let's try and see the dry run for this. If you will see here, initially in this problem, what will happen is we'll take a empty map here to store the frequency of the prefix Zors, and we'll start traversing from the starting index. So initially what we will do is, initially you can observe that we will take the Zor of this starting element, that is the element at the index 0. Now when we take the Zor, the prefix Zor becomes equal to k, and as of now we will try to check that whether this Zor with k exists or not. So whether 2 exists or not in the map. So as of now 2 does not exist in the map. So we'll move forward by putting this Zor inside the map. So what will happen now is, you can see that the Zor that we got earlier was 4. We have put this inside the map, and now we'll move forward. Now we'll be at this index. Now when I take the Zor, what happens is, when we take the Zor with this element 2, now the prefix Zor itself becomes equal to 6. So it becomes equal to k here. So since it becomes equal to k, the Zor from this index till this index itself becomes equal to k here. So I should increase my result here. So what we will do is we'll update the result will equal to 1, and we'll store the Zor also. So the Zor 6 will be stored inside the map here with the frequency as 1. Then we'll move further, and now what will happen is we'll be at this particular element. Now when I'm at this particular element here, so you can see that the Zor will be what? The prefix Zor till this point will be equal to 4. Now what will happen is, with respect to 4, you'll increase the frequency, so it will become equal to 2 inside the map. And you will also check that whatever Zor you have got till this point, Zor with k, does it exist? Does 2 exist inside? Because as of now my Zor value is what? My Zor value is 4. I'll check whether 4 Zor k, that is 2, exists in the map or not. So it does not exist. So this means there is no subarray in between which is having the Zor as k here. Okay, so we'll move further. So you can see here we'll update the frequency of 4 as 2, because the Zor value 4, prefix Zor 4, it is occurring 2 times. Then after that we'll move further. Now we'll take the Zor of this particular element as well, and now my Zor will become equal to what? My Zor till this point will become equal to nothing but, you can say, 2 here. Now after that we'll check whether X Zor with K, the Zor so far, Zor with K, does it exist in the map or not? So you can see here as of now we have 2 Zor with 6, it will be equal to 4. Does 4 exist in the map? Yes, it exists 2 times. If it is existing 2 times, so there are 2 subarrays internally which have the Zor equal to nothing but 6 here. How? You can see here that one subarray, if you see, we are considering the subarrays till this index. Correct. We are considering the Zor till this index. Now I checked, as of now my Zor was equal to what? My Zor was equal to X. Okay. And I checked whether X Zor K exists in the map or not. So X Zor K is what? Like as of now till this point, the Zor is equal to nothing but 2. Now 2 Zor with 6 is what? 2 Zor 6 is 4. 4 is occurring 2 times inside the map. So this means there is one subarray, that is this particular subarray 6 only, which is having the Zor equal to K, and another subarray is this particular subarray, that is 2, 2 and 6. It is also having the Zor equal to K or Zor equal to 6 here. So that is why the answer will be updated, or the result will be updated to the frequency of X or K, that is plus 2 will be done. So result will be equal to 3 here. Okay. Now after this, what will happen next is, at this point you will see that we'll update the frequency of the prefix or 2 inside the map as 1, and we'll proceed further. Now after that, what will happen is we'll be at this particular last element, and when we are at this element, we'll take the Zor. The Zor will be equal to what? The prefix Zor will be equal to 6. So since the Zor itself is equal to K, so we'll increase the counter here, and we'll try to check whether the Zor that we have got so far, Zor with K, does it exist in the map or not? So it does not exist in the map, because X Zor K is equal to 0. We'll try to check it. Does it exist? No, it does not. So there is no internal subarray, but the subarray from the starting till this point overall has got the Zor as k here, Zor as 6. So we'll count it, we'll update the result. So result will be equal to what? You can see result will be equal to 4, and the frequency of this particular Zor 6 will be updated as 2 inside the map. And then after that, my traversal is over, and the final result is basically equal to 4 here. So as I told you, there will be two scenarios. If the Zor, prefix Zor that I keep on taking, if it's equal to k directly, in that case what we are going to do is, in that case we are going to update the result directly. Otherwise, if the current Zor that I have got till the index I, Zor with K, does, if it exists, so this means that there will be an internal subarray which will be having the Zor equal to K here. So we'll increase the count, or we'll increase the result with whatever is the number of XOR K that we have seen already before the index. So you can see here the code is going to look something like this. Basically, initially we'll update the result as 0, then we'll declare a map here, then we'll have the prefix XOR equal to 0. Basically my X value that I was considering, we are taking it as prefix XOR here. Then after that, we'll take the XOR of the current ith element of the array, and what we are going to do is, we are going to say that if there exists prefix like the current XOR XOR with k, if it exists inside the map, then whatever is the frequency of it, increase your result by that. If it does not exist, then increase your result by 0 only. Now after that, if the prefix XOR itself becomes equal to k, then also you need to update the result here. And then after this is done, what you need to do is you need to basically say that whatever is the prefix XOR as of now, whatever is the XOR as of now, you'll update its frequency by 1 here inside the map. Okay, so if it is coming for the first time, its frequency will be equal to 1. If it was already there, then whatever was the previous frequency, you will do a plus 1 to it. And at the end, you are going to return the result here. Now, the time complexity for this code will be what? The time complexity for this code is going to be nothing but order of n, because we are going to linearly iterate throughout the array only. And the space complexity would be equal to nothing but order of n here, because we are trying to use a hash map here. Now, let's try and submit this code and check if it is getting accepted or not. Let's submit this code and check if it is getting accepted here. So you can see that my code is getting accepted. I hope that you have understood this. Please make sure to comment understood or clear in the chat. Thank you for watching this video.